So we're saying it louder than usual.
Oh my God. Oh dear. I'm really in trouble. Oh dear. Okay. She's my. You guys, she's my boss. Okay, just so you know. Okay.
Blame it on us.
Okay.
Yeah. Blame it on the students.
All right. Okay. So, okay, guys. So yesterday we talked about T-charts, right? And we talked about graphing, and then I gave you homework that didn't involve graphing. Sorry. So today you're going to have homework that I should have given you yesterday about T-charts and graphing. Okay.
That's not hard.
However, so you guys have to stop talking back there. Okay. However, I want to show you a few things that to make certain types of problems easier, certain types of T-charts easier. So if I gave you, here's our first example. Let's say I gave you y equals 1/2 x plus 3. Okay? Now, we had one like that on the homework. I don't know exactly what it was, but it was 1/2 x plus something, right? Plus 2? Okay. So I'm changing it dramatically. Look at that, right? Okay. And I told you to always choose 0, 1, and 2 for your x, which is that your independent or your dependent variable?
Independent.
Independent, right? We choose x independently of y. Y is dependent on what we choose for x, right? And so, so I told you to do it this way, and I'm gonna do it two ways. Y is equal to 1/2 x plus 3. I told you to do it this way. X, y, there's your T-chart, and I said do 0, 1, and 2. Now, 0 times this is 0, whoops, right? So y is equal to 0 plus 3, which is 3. Yes?
Yep.
Pretty easy. 1 times 1/2 is 1/2. So 1/2 plus 3 is 3 1/2, right? 3 1/2, just so you don't know this, is the same thing as 3 plus 1/2, right? Do you guys know that? A lot of people don't teach that. But that is exactly the same thing as this. So when you put the 1/2 first, just put it on the other side. It's just 3 1/2. So we know that that's 3 1/2, right? And then 2. Now this is interesting. So this is interesting. On this one, we got a fraction. This one we didn't. And this one, we're not going to get a fraction. 1/2 times 2. What's that?
1.
Half of 2 is 1. 1 plus 3 is 4. Now, can somebody explain to me why we're not getting fractions on 0 and 4? In particular, 4. James.
Because you're multiplying the half. So like if we were to keep going right now, like 0 plus 3 and then 1. So it would be a pattern of fraction, not fraction,
Right.
fraction, not
3
fraction.
would be a fraction, right? 4 would not be, 4 would be, half 4 is 2 plus 3 is 5, right? Right?
Yes.
And then 5 would be a fraction again. Do you see that?
I know why, Gary.
Okay, why?
Because
Same
the
one.
even numbers are gonna balance it out, and the odd numbers are not.
Okay, so did you hear what James said?
Yeah.
He said even numbers would balance it out. In this problem, he is correct.
Yes.
That is
I was
not
talking
that is
about
not
this problem.
exactly true with every problem with a fraction.
Yeah.
But can anybody describe what you'd have to do to always get a not a fraction? So Jan, what would you say?
You'd have to write, like, I would start with the smallest thing, even numbers that are divisible by 2.
Yes, you see the denominator? The denominator of this fraction is 2. So every time you have an x, choose an x that is a multiple of 2. What's a multiple? Like 2 times 1 is 2. 2 is a multiple of 2. 2 times 2 is 4. 4 is a multiple of 2. 2 times 3 is 6. 6 is a multiple of 2.
Even numbers.
Right? Yeah. Multiples of 2. Not necessarily even numbers. Multiples of
But
2.
you have to use 0, 1, 2,
In this case, even numbers works, but I'm saying it's really multiples of 2 that's going to work for this. Because
So,
I'm trying to teach you something that works for all of them, right? All of the ones with fractions. Rosemary.
so if the denominator was, say, 3, choosing multiples of 3.
Yes, exactly. So notice, if the denominator is a 2, I would choose this. My x's would be, I always choose 0. I always choose 0. Why? Because it's so easy. Y is 3,
And 3.
right?
No, you just said why is it so easy?
When x is 0, y is 3, right? It's easy. 0 is the easiest one to choose.
0 will cancel everything out.
Then I see, oh, there's a fraction here. I'm going to make it a 2. I'm going to use the denominator. I'm going to put the 2 here, right? And then I'm going to do twice that denominator, which is 4. And I put it there. And then I find my y's, right? Does that make sense? So now, let's try a different one.
You do it like odd, then?
Why would you do it all?
Because I feel like it.
All right, so here's another one. Number 2. Let's say I had
Why?
y is equal to 1/3 x plus 4. Okay, so Lucas, what would I choose?
Can I use the restroom?
Oh, absolutely. That was very insightful. Thank you so much. Rosemary.
0, 3, and 6.
0 is always my first one. The second one is the denominator, right? Right? 3. And the third one is always twice the denominator, which is 6, right? And then you'll have no fractions here. Now, is it absolutely essential to have no fractions here? No. If it's easy to graph with a fraction and you'd rather do 0, 1, and 2, that's fine. But sometimes it's hard to do with a fraction. Like, what if I gave you this? What if I gave you y is equal to 4/5 x plus, 1? So you guys paying attention? What if it's 4/5 x plus 1? That's kind of scary. So I gotta think of what. Do I really? Is it going to be easy if I get like 3 2/5, or 3 1/5, or 3 4/5? Is that going to be real easy to graph accurately?
No.
Not really, right? Because you got to divide that little teeny square into 5 equal pieces, and then you got to put your dot exactly in the right spot. That's not easy. Don't you agree with me? It's easier to use a graph and have it be on the corners, you know what I'm saying, on a graph, than somewhere in the middle somewhere, right? So what would I do? First one is always
0.
Second one will always be 5, the denominator. The third one will always be twice 5, which is 10. So let's try it. When x is 0, y is 1, right? When x is 5, the 5's cross out, I get 4.
4.
Plus 1 is 5, right? When x is 10, 5, when this is 10, right? 5 goes 5 once, 5 goes to 10 twice. 2 times 4 is 8. Easy to graph. Very easy. I just wanted to be sure you guys were awake, right? Don't worry, Lucas, they're just doing me.
Gary, so the rule is
So guys, let's have it come back together again. Rico. Yes.
So what I'm getting is, if it's a fraction, get the bottom number, make it the second number, and then multiply that times 2.
Exactly.
And then, so that would be 5, 10, 15, 20, or it would be 5, 10, 50, or would it be 5, 10, 15, 20?
Yes.
So
If
it
you
would be
wanted to
5,
keep
10,
going.
15, 20.
If you
Oh,
want,
you do 0, 5, 10.
it would be 0. But you're only doing three problems, 3 numbers, right?
Yeah, I know, but I'm talking about if we were to keep going.
If you were to keep going, then yes. Because those are all multiples of that
No, we're
number.
doing multiples of the number.
Multiples of the number.
I got it.
Exactly. All right. Do you guys need me to keep going?
Nope.
All right, Jan, do you have something to share?
I know a really, really, really easy way to do fractions.
Awesome. You want to? Oh, I can't have you come up. Tell us.
So you would use the y
Wait. I'm sorry. I need it quiet. Okay, go ahead.
So on the graph, you use the y-intercept, which is the positive 4
Yeah.
on that side, and then you just graph positive 4, and then you use the rise of the run, which is 1 over
Did Matt teach you that?
Yeah, and then you would
He
go
did, really?
rise up 1, and then go over 3.
Oh my
Rise up
God.
1, go over 3, and then
So that's the
one.
first shortcut. Yeah, that's it.
I don't
That's awesome.
understand it because I can't see.
Yeah, don't worry about it. That's another lecture. I'm going to be teaching that in another lecture.
Okay.
That's awesome. I didn't know you guys knew that. He hasn't taught that many times in the past. So usually when I teach it, it's like new. So that's interesting. That's great. All right, very cool. So I'm going to stop this lecture and give you